Converting units with dimensional analysis. Say I have a recipe that calls for 3 tablespoons of sugar. However, I can only find my teaspoon measuring spoon. What do I do? Well, if I know that 1 tablespoon is equal to 3 teaspoons, I can figure out how many teaspoons I actually need. So if I have 3 tablespoons, and I know that for every tablespoon there are 3 teaspoons, I know that I need 9 teaspoons of sugar. That's all dimensional analysis is. It's converting from one unit to another, in this case the tablespoon into the teaspoon, using something called a conversion factor. And a conversion factor is just a fraction that relates to 2 units that you're trying to convert from and into. Let's take a look at this example. We have $150. What if I wanted to know how many pesos $150 is? So I have $150, and I know the currency converter is that for every $1, there are 13.27 pesos. So am I going to multiply or divide by 13.27? In this case, I'm going to multiply by 13.27, and I will show you with units why that works out. I'm going to set up a fraction where I put the dollar here in the numerator, and I'm also going to put the dollar in the denominator. I'm going to put my 13.27 pesos in the top, and the reason I want the dollar in the bottom is so that the units will cancel out. So this shows me that I do in fact need to multiply by 13.27 and not divide. And so I get 1,990 and 50 pesos. Okay. This problem is sort of a challenging dimensional analysis that we will go through now, but then we will come back to at the end. If I know that I have $1 US and I would like to know how many New Zealand dollars that is equivalent to, and I am given the following conversion factors. I am not given a direct conversion between a US dollar and a New Zealand dollar, but what I am given is a bunch of in-between conversions that will get me from A to B. So I know 1 US dollar is equal to 0.89 euros. I know 1 euro is equal to 12.07 pesos. I know that 1 peso is equal to 0.72 Hong Kong dollars, and I know 4.49 Hong Kong dollars is equal to 1 New Zealand dollar. So using those 4 conversion factors, I can go from a US dollar into a New Zealand dollar using dimensional analysis. Now, it's sort of confusing though, because in some situations you're going to multiply by the conversion factor, and sometimes you'll be dividing by the conversion factor number. So here's the final answer, and let me go through it with you. So you start off with your 1 US dollar right here, and to go from US dollars to euros, I am going to multiply by 0.89 euros. Now, the reason that I want to multiply by the 0.89 euros and not divide is because I want the dollar in the bottom, so it will cancel with the dollar in the top here. Now, to go from euro to peso, I am going to put the euro unit in the bottom because I want it to cancel out with the euro that's in the numerator, and I'm going to put the 12.07 pesos in the top. For my third conversion, I'm going to go from pesos to Hong Kong dollars. Again, I'm going to put the peso in the bottom part of my fraction so that it cancels with the peso that is up there in the numerator. And the 0.72 Hong Kong dollar will go in the top here. And then finally, my last conversion will be from a 4.49 Hong Kong dollars, again in the denominator, and then the 1 New Zealand dollar in the numerator. And so I multiply everything in the numerator across, I get 7.73 New Zealand dollars. I multiply everything in the bottom across, I get 4.49, and I finally divide the two to get 1.72 as my final answer. So that last problem was sort of like the advanced level of dimensional analysis. We are going to start simple and then work our way to those sorts of problems. A little bit of math review that you need to know before you start dimensional analysis. If you have three fractions and you're multiplying them together, the way you would do this is you would find the product of the numerators, 3 times 4 times 7, and that would be 84. And then you would multiply the denominator products together to get 5 times 9 times 8 to give 360. Then you divide the numerator by the denominator to get a decimal. Okay, and that is all dimensional analysis is mathematically. The only tricky part is putting the units in and putting the units in the right spot. When you multiply fractions with units, units work the same way as numbers. If a unit appears in both the numerator and denominator, the unit will cancel. So if I have a liter here in a numerator and a liter in this fraction's denominator, they will cancel the number 1. And so the unit of my final answer, the only one that did not cancel out, would be the milliliter. And so that would carry over to my final answer over here. Vocabulary. Dimensional analysis. If you were asked what dimensional analysis was, like on a test or a quiz or in class, dimensional analysis is just a fancy word for the process of converting one unit to another through the use of conversion factors. A conversion factor is a fraction that has different units in, should not be an apostrophe there, that drives me crazy, in different units in its numerator and denominator, has a 1 somewhere in its numerator or denominator, and the total value of the fraction equals 1, meaning that you haven't changed the equivalence of the two types of units you're using. Examples of conversion factors: 12 inches over 1 foot. So it is a fraction. There are two different units, inches and foot, and the equivalent is still 1. There are 12 inches in 1 foot exactly. 1 gross is equal to 144 firecrackers. 365.25 days equals 1 year. 1,000 meters equals 1 kilometer. 500 sheets equals 1 ream of paper. 1 liter equals 1,000 milliliters. 2 shoes equals 1 pair. 1 century equals 100 years. And 12 eggs equals 1 dozen. So these are all examples of conversion factors. You can inverse any of those. So the 12 eggs and the 1 dozen, you could switch the dozen to be on top, the eggs to be on the bottom. These are all interchangeable, in other words. Conversion factors show the relationship between two different units. You know that there are 1,000 meters in 1 kilometer. So a conversion factor would show the relationship between meters and kilometers in fraction form. So you could write 1,000 meters over 1 kilometer, or you could write 1 kilometer over 1,000 meters. Those are each equal conversion factors. Suppose you wanted to convert 4,567 meters into kilometers. And you were asked to do that conversion. How do you do this? Do you multiply or divide? Using this example, I will walk you through the 5 steps to easily convert from meters to kilometers using dimensional analysis. Now, I understand that in middle school, you probably learned this: King Henry died unexpectedly drinking chocolate milk acronym to help you convert from a metric unit into another metric unit. You would have said, okay, well, I know my base unit is the meter. I'm going to the kilometer, so I'm going to move my decimal point over to the left 3 times. There's my final answer. If you are going from a metric unit to another metric unit, you can do this shortcut. However, in this class, you aren't always going to be going from metric to metric. You might be asked how many inches there are in 4,567 meters, or how many feet are there, or how many fathoms. So you can tell from those 3 units, you wouldn't be able to do that shorthand method to convert. So even though I know this problem is very simple, you just move the decimal place to the left 3 times, we're going to go through this example using the 5 steps of any dimensional analysis problem, which become more complicated when you go between the metric and the English and the English and the metric, or between English and English units. So step 1, you change your given into a fraction simply by placing it over the number 1. Okay, so dimensional analysis, it's all about using fractions and units to get your final answer and converting the units. Okay, the first step is take your given, put it over the number 1 to make it a fraction. The second is to write your conversion factor that has the units you wish to get rid of in the denominator. So we have meters. That means that the meter has to appear in the denominator of your conversion factor. This right here is your conversion factor. This guy right here. Okay, so the unit you're trying to get rid of goes in the denominator, and the unit you want goes in the numerator. Step 3, multiply your given by the conversion factor. When you do this, the unit of your given cancels out, so your meter should cancel out with the meter that you put there on the bottom, and you're left with the unit you wish to convert on the top, wish to convert to on the top, which is a kilometer. Okay. Step 4, multiply the numerators together. So 4, 5, 6, 7 times 1 gives you 4, 5, 6, 7. Multiply the denominators together. 1 times 1,000 gives you 1,000. The unit that carries over that was not canceled out is the kilometer, and simply divide the two numbers together to get a decimal. Change your fraction back to a decimal by dividing the numerator by the denominator. That gives you the digits in your answer. The only unit left carries over from the numerator. So your final answer is 4.567 kilometers. All right, so let's do a couple of these examples. These, again, are metric to metric conversions. I know you can do them using that shortcut, but we're going to do them using dimensional analysis. So we have 300 kilometers. Step 1 is to put it as a fraction. Okay. Step 2 is to write your conversion factor. Your conversion factor is this little fraction. The unit I'm trying to get rid of, which is the kilometer, is going to go down here. My advice is to always put the units in first. One of the biggest mistakes I see people do is they try to put the numbers in quickly, and that's where you run into mistakes. So the first thing you want to do when you do your conversion factor is put your units here in the bottom. The unit you're trying to get, which is the meter, is going to go up here. Okay? Now, the second mistake that people make is they don't put the 1 and the 1,000, the conversion numbers, in the right spot. Here's the trick. You always have to have a 1 in your conversion factor. So does the 1 go next to the meter, or does it go next to the kilometer? The 1 is always going to go next to the larger measurement, the larger value, the larger distance. So in this case, a kilometer is larger than a meter. And this only applies to metric conversions. When you go from metric to English conversions, you will have a table that gives you what those numbers are. Okay, so you put the 1 next to the larger measurement, and then you should know by this point how many meters there are in a kilometer. And you should remember that there are 1,000. So the kilometer cancels with the kilometer, and we end up with 300,000 meters over 1, which just turns out to be 300,000 meters. Sig figs. So in this number, we have 1 sig fig. When you multiply numbers together, you go based on the smallest number of sig figs in your two initial numbers. So your answer is going to have 1 sig fig. This conversion factor right here is an exact number. It's not rounded. It's not a measurement. So the 1,000 and the 1 actually do not count towards your sig figs. Okay. Usually your sig figs come from your given. This right here, these are not measurements. These are exact numbers. There was no rounding. There was no estimations in them. They're exact, like by definition. There's 1,000 meters in a kilometer. So there's no guessing or estimation. So there are no sig figs in that conversion factor. All right, let's take a look at this. 400 kilometers to meters. So we're going to start with our 400 kilometers, put it over 1. Next comes my conversion factor. This unit is going to be put in the bottom of my conversion factor because I want these two to cancel out. And then the meter goes in the top. Where does the 1 go? Does it go next to the meter or does it go next to the kilometer? The 1 goes next to the unit that is larger. So in this case, the kilometer is bigger than a meter. And you need to know that there are 1,000 meters in a kilometer. These will cancel, and you end up with 400,000 meters. Sig figs, the initial given has 1 sig fig. The conversion factor does not go into your sig fig calculation because, again, it's not a measurement. It doesn't have sig figs. It's an exact number. Your sig figs are based on your 400 kilometers. Here is a dimensional analysis problem that is not in the metric to metric category. It is a metric to English unit. So whenever you're going from a metric to an English conversion, the conversion factor should be given to you somewhere in a table. Okay, so here you don't have to determine where the 1 goes. The 1 should be shown next to the unit it belongs with. So the procedure is the same though. You start off with your given 800 centimeters, multiply that by the conversion factor. The unit that goes in the bottom here is the centimeter. You want it to cancel with the centimeter that is given. And then inches go in the top. Here, you use your conversion factor directly. The 1 is next to the inch, so the 1 goes there. The 2.5 is next to the centimeter, so the 2.5 goes down there. So when you multiply this together, you get 800. The centimeters cancel. The unit is the inch, and the 2.5 goes in the bottom. Now, because you want to put this into a decimal, you will divide 800 by 2.5, and you will get 320 inches. As far as sig figs go, there is 1 sig fig in this number. Now this 1 inch to 2.5, that is a measurement. There are not exactly 2.5 centimeters in an inch. That is a rounded estimation conversion factor. Usually English to metric conversion factors will count towards your sig figs, not metric to metric. So the 1, that's not a sig fig because that's an exact number. So you're looking at the 2.5 and you're looking at the 800. So when you divide, you're going to go with the one with the least number of sig figs, which is the 800. So you'll have a number rounded to 300 inches. Let's take a look at this one. This is an a metric to English conversion. 15 kilograms, write your conversion factor. Kilograms goes in the bottom, pounds goes in the top. It tells us in the conversion factor, the 1 will go next to the kilogram, and the 2.2 will go next to the pounds. So here, 15 kilograms will cancel with the kilograms in the bottom. Multiply the numerators together. 15 times 2.2 gives you 33 pounds, and in the bottom you end up with 1. sig figs, you have 2 sig figs here. You have 3 sig figs here. This one and this one don't count towards sig figs because those are not measurements, those are exact numbers. So your answer should have 2 sig figs, which is 33 pounds. All right, let's do one more. We have 30 feet. This is a English to English conversion. So we're going to set up our conversion factor. We're going to put feet in the bottom. We're going to put miles in the top. The miles gets the 1. The feet gets the 5280. The feet cancels with the feet over there. So we end up with 30 miles over 5280. 30 divided by 5280. 30 divided by, 30 divided by 5280. 0.00568 miles. My answer is going to be based off the 30 feet with the 1 sig fig, so 0.006 miles, which you could put in scientific notation if you wanted to. Using multiple conversion factors. So in the previous examples, we saw one-step dimensional analysis problems where there is a direct conversion factor that allowed you to go from A to B. Sometimes you cannot convert one unit directly to another because you don't know the conversion factor for your 2 units. When this occurs, convert to your base unit first, the meter, the liter, or the gram, and then convert your base unit to the unit you wish to end up with. So in other words, sometimes you have to use 2 or 3 step conversion factors in order to get to your final answer. So for example, how many kilometers are in 1.56 centimeters? So you are expected to know that there are 100 centimeters in a meter, and you are also expected to know that there are 1,000 meters in a kilometer. But from the metric notes we did a couple of weeks ago, you are not expected to know how many kilometers or how many centimeters there are in a kilometer. If you know that because you've just learned it or you just can figure it out, that's great. But for those of you who don't want to memorize that, converting between the 2 units just becomes a matter of converting to the base unit first. The base unit is the unit that is common between the kilometer and the centimeter. So here, the base unit is the meter. So the game plan is a 2-step problem. We are going to convert from the centimeter into the base unit of meter in a first step, and then we will convert to our final unit in a second step. So it will require the use of 2 conversion factors. So write your given as a fraction like before, 1.56 centimeters. Write your conversion factor with centimeters in the denominator, your base unit in the numerator. So 1 meter goes on top. Again, meter is bigger than a centimeter, so it gets a 1. And you are expected to know that there are 100 centimeters in a meter. Step 3, write the conversion factor, the second conversion factor with meters in the denominator and kilometers in the top. So now you're going to go from meters to kilometers. The meters will go in the bottom, the kilometers will go in the top. The 1 goes next to the larger measurement, which is the kilometer, and you are expected to know to put 1,000 next to the meters because there are 1,000 meters in a kilometer. Step 4, multiply the numerators through, multiply the denominators through. The unit that is left standing is the kilometer, which is what you were hoping for because that is what you are trying to convert into. And then divide through to get a decimal. As far as sig figs go, these numbers right here do not have sig figs. They are exact numbers. So your sig fig is based on your given, which is 1.56, which is why your answer will have 4 sig figs when you get. All right, let's take a look at a couple of these 2-step or multi-step DA problems. We have 28.5 quarts and we want to get to liters. So we're given this nice conversion table on the top, and we look and we look and we see that there is no direct conversion between quarts and liters. What I do see, though, is I see a conversion between quarts and milliliters. So if I know how to go from quarts to milliliters, which is an English to metric conversion, and I should know how many milliliters there are in a liter because I had to memorize that during the metric unit chapter or section, I can use that conversion factor to go from quarts into liters. So I'm going to start with the quart. I'm going to go to the milliliter in a first step, and then I will go to the liter in the second step. So here, to go from quarts to milliliters, we're going to do the same thing. Put the quarts in the bottom, put the milliliters in the top. Use the conversion factor that is given with 946 mils on the top, 1 quart on the bottom. The quart cancels with the quart, and now my answer would be in milliliters. Because I need to go to liters, though, I need to do another step. So now I'm going to go from milliliters to liters. I'm going to put liters down here, mils down here. This conversion factor is not given in the table because I'm expected to know how many milliliters there are in a liter. What's bigger, a milliliter or a liter? The liter is bigger, so it has a 1. And how many mils are in a liter? 1,000. So this cancels with this. So you'll multiply 28.5 times 946 times 1,000, and then you will divide that by 1, which happens to be a very large number, 26961,000 mils. As far as sig figs go, we have 3 sig figs here, 3 sig figs here. This does not count for 1 sig fig because those are not measurements. So your answer should have 3 sig figs. So your answer will be 2.70 times 10 to the 3, 4, 5, 6, 7 times 10 to the 7th milliliter. All right, let's do this one. 15.25 feet, 2 kilometers. So I look and I look, and I see that I have a conversion trying to go from feet to kilometers. I see I have a feet to mile, and I have a mile to kilometer. So my plan of attack is I'll start with my feet, and I'll go to my mile first. Then I'll have to go to kilometer. So 15.25 feet, make it a fraction. My first conversion factor, feet on the bottom, miles on the top. So I'm going from here to here. I'm going to use the 1 mile equals 5280 feet in my first conversion. The feet cancel out. Now I can go from miles to kilometers. I'm going to do a second conversion factor, miles in the bottom, kilometers in the top. This conversion factor over here tells me that in 1 mile, there are 1.6 kilometers, and the miles cancel out. So here, I'll have 15.25 times 1.61 divided by 5280, and I get 0.00465 kilometers. My answer should have, so I have 4 sig figs here, I have 3 sig figs here, and I have 3 sig figs here. So my answer is going to have 3 sig figs, which is what I have there already. All right, 20 pounds to grams. So I see that I have a pounds to kilogram conversion, but not a pound to gram. But if I go from pounds to kilograms, which is an English to metric conversion, you have to memorize kilograms to grams, and so you know what that second conversion will be. So we'll go 20 pounds, put that over 1, pounds down here, kilograms up here. We have 1 kilogram, 2.2 pounds, pounds cancel out. And the next step, grams to kilograms. Where does the 1 go? It goes next to the bigger measurement, which is the kilogram. And you should know there are 1,000 grams in a kilogram. This cancels. Oh, shoot. Whoops, I screwed up. Let me go back. So, my bad. I was going too fast. So, I'm sorry. We're going to put the kilogram down here, the gram up here, and then we're going to multiply by 1,000 so that the kilograms cancel out. So that is a good example of how units can help you determine if you're doing the right thing. So for this one, I get 9090 grams. For sig figs, I have 1 sig fig here. I have 3 sig figs here, 3 here. These don't count for sig figs. So I need to have 1 sig fig. So I'm going to go 9,000 grams. All right, 55 kilometers to millimeters. So this is a metric to metric conversion. However, I do not expect you to know how many millimeters are in a kilometer. If you do know, great. If not, do not worry. You're going to go from the kilometer to the millimeter. What is the base or common unit between a kilometer and a millimeter? The base unit is the meter. So we'll have to convert to that first in a 2-step problem. So 55 kilometers, we'll put kilometers down here, meters down here. The kilometer is bigger. There are 1,000 meters in a kilometer, which you should memorize and have known by now. The second step is to go from meter to millimeter. Meter goes in the bottom, millimeter goes in the top. The meter is bigger, and there are 1,000 millimeters in a meter. So here, you're going to have a giant number, 1, 2, 3, 1, 2, 3 millimeters. Sig figs is based on the 55 kilometers that is given. All right, 55 centigrams to kilograms. So we have centigrams, we need to get to kilograms. This is a metric to metric conversion. You aren't expected to know how many centigrams are in a kilogram, but you are expected to know how many centigrams there are in a gram and how many grams are in a kilogram. So the base common unit between those two prefixed units is the gram. So we'll go 55 centigrams, centigram down here, gram up here. There are 100 centigrams in a gram. These cancel, and then go from gram to kilogram. 1 kilogram has 1,000 grams in it. So here we will be taking 55, dividing it by 100, and then dividing it by 1,000. So we get 0.00055 kilograms, and your sig fig is based on the 2 sig figs in the 55 kilograms. No, 55 centigrams. All right, let's do this one. A European kayak paddle is 228.6 centimeters long. How many feet is this? So we're going to go from centimeters to feet. We need to figure out a common unit between those two. And up here, I see that there is a link between centimeters and inches. And you know that there are 12 inches in a foot. So we're going to go from centimeters to inch and then inch to feet. So we'll go centimeters to inches. And again, I cannot emphasize this enough. Put your units in first and then put your numbers in second. Centimeters will cancel. And then you go from inches into feet. 1 foot has 12 inches. The inches cancel. 228.6 228.6 divided by 2.54 divided by 12, you get 7.5 feet. Your sig fig is based on 4 sig figs here, 3 here, 3 here, so you want 3 sig figs, so 7.50 feet. Even if your calculator gave you just 7.5, your calculator doesn't know how to do sig figs, so you would have to add that extra 0 to indicate the sig figs. So if we have the question, you have 1 New Zealand dollar and you want to know how many Vietnam dongs there are. There's not a direct conversion between the New Zealand dollar and the VND. So you are given, though, 3 different conversion factors between the New Zealand dollar and the rupee and the Egyptian pound, and the Egyptian pound and the Vietnam dong. So what we're going to do is we're going to start off with 1 New Zealand dollar, put it over 1. We're going to go from New Zealand dollar to rupee. We're going to put the 1 New Zealand dollar down there, the 33.32 rupees up there. Next, I'm going to go from a rupee to an Egyptian pound. I'm going to put 9.36 rupees down there, 1 Egyptian pound here, and then finally 1 Egyptian pound and 2,518 Vietnam dong there. The New Zealand dollar cancels here, the rupee cancels here, the Egyptian pound cancels here, and my final answer will have 33.32 times 2,518 divided by 9.36, and I get 8,963 Vietnam dongs. I should have 3 sig figs, so my answer should be 8,960 VND. Dimensional analysis is a way to convert a measurement from one unit to another through the use of conversion factors. A conversion factor are fractions that have different units in their numerator and denominator, have a 1 in either the numerator or denominator, and have a total value of 1. When you finish with your DA, the only unit left will be in the numerator of the last conversion factor. Often more than one conversion factor is required to change units. Sometimes you must convert your given to a base unit, such as the meter, liter, or gram, before you can convert it to another unit. For example, 13.2 kilograms equals how many milligrams? You would first convert kilograms to grams, then grams to milligrams.